All right, hey everyone. So this is day 2 of our probability series. Yesterday we kind of did an intro with sample spaces and theoretical and experimental probability. Today we're going to go over independent versus dependent events. So let's go ahead and get started here. Go ahead and flip to the second page of your notes. Day 2. Probability sample spaces, independent versus dependent events. All right, so they are fairly obviously named, hopefully. Independent events are two events that do not impact each other. So two events are independent. If they don't impact each other, they don't affect each other. I always say impact because I'm never sure if it's effect or effect. And yeah, so anyways, if they don't impact each other, it's a lot easier that way. Anyways, some of the vocab that you'll see to let you know that it's an independent event. If you see the words with replacement. Oof, looks like it's all one word. That is two words, with replacement. Or if you see the words put it back. Like I took a sock out of the drawer and then I put it back and chose another one. That would be independent events. Or if they're completely unrelated events. Like if I rolled a die and I spun a spinner, those are completely unrelated. They can't affect each other. Or if I flipped a coin and then I flipped a coin again, whatever you get on the first coin flip doesn't affect the second coin flip. So those would be independent events or unrelated events. Okay. So when we talk about probability of independent events, you just multiply the probability of the first event by the probability of the second event. And that's pretty much how all compound events go. So let's try one. Let's find the probability that I flip a coin and get heads twice. Okay. So what's the probability of getting heads the first time? Well, there's only one side that has heads and there's two possibilities, right? So 1/2 is the probability of getting heads the first time. We're going to multiply that by the probability of getting heads the second time. And it turns out that it's the same probability getting heads the second time. So times 1/2 again, that's the probability of the second heads. And when you multiply fractions, you multiply straight across. So 1 times 1 is 1, 2 times 2 is 4. This is the probability of both of them together, of getting heads 2 times in a row. If you were asked for the percentage, 1/4 is also known as 25%. 25% of the time you'll get heads twice in a row. Okay. Let's try another one. This time we're going to have a bag of marbles. So let's draw a picture here. We're going to make a bag of marbles. And your bag of marbles can be fancy or not fancy. That kind of looks like a green pomegranate. Anyways, in my bag of marbles, we're going to have 3 blue marbles. If you want to just write like the letter B or something, if you don't have colors, that's fine. B can represent blue marbles. There's going to be 4 green marbles. And again, if you don't have colored pencils or pens, then just write the letter G instead. Those are kind of dark anyways. And then 2 orange marbles. All right, so there's my bag of marbles. And we want the probability that I pick a blue marble. and then a green one. With replacement. Which means that I picked a blue, I pick a blue one, I put it back, and then I pick a green one. All right, so those words with replacement should clue us into the fact that this is independent events. All right, so first I want the probability that I pick a blue marble. So that means, let's see, there are 3 blue marbles in there. That's my top number. And there are 9 total marbles. So we have the number of blue over the total. That's the probability that I will pick a blue marble. Then we want to multiply by the probability of picking a green marble. There are 4 green ones. And there's still 9 total because I put the blue one back after I picked it. So then we're going to multiply these fractions again. 3 times 4 is 12. 9 times 9 is 81. This fraction does reduce. Both of these are divisible by 3. If I go 12 divided by 3 and 81 divided by 3, 12 divided by 3 is 4. 81 divided by 3 is 27. If you're not sure on the reducing fractions, a lot of calculators will do it for you. So you can use like Desmos or something if you do 4 or if you do 12 over 81 as a fraction on there and then click the little fraction button next to it, it will reduce it for you. But this is also a good skill to have, to know what things multiply to get other things. So it's something that I would work on like this. Anyway, that's what we're looking to do. That's independent events. You just multiply the 2 probabilities. And then, of course, reduce your fractions. Dependent events. They're going to be very similar to independent events, and they're going to behave very similarly. 2 events are dependent if they do impact each other or affect each other. So, dependent. Let's see. So some words that we're going to see for this. Without replacement. So we had with replacement before. Now it's without replacement. Or if you see like don't put it back or something like that. Like I picked a sock from the drawer and then I kept it out, or I didn't put it back and I picked another sock. Or I picked a marble out of a bag and I didn't replace it and I picked another marble, that sort of thing. So we're going to use this same bag of marbles here that we've been working with. So same bag of marbles. Maybe we want to write down that there were 3 blue, 4 green, and 2 orange. Just to kind of keep records for ourselves here. This time we want to know the probability that we pick a blue marble. And then green. So just like last time, but this time it's without replacement. All right. So anytime we see those words without replacement, we know we're dealing with dependent events. So the probability of picking the blue marble the first time, it works the same way. There were 3 blue marbles. There were 9 total. 3 over 9 is still the probability of the blue marbles. There were 3 blue, 9 total. But now I've picked a blue marble out. So how many marbles are left in the bag? 8. There's no longer 9 marbles in there. There's only 8 now. So now when I go to pick a green one, there's still 4 green ones in there, but there's only 8 total. So this is our new total after I've picked one out. So now we can go through and multiply. It works the same way. 3 times 4 is 12. 9 times 8 is 72. There's our fraction this time. And this one also reduces. Both of these are divisible by 12. 12 divided by 12 is 1. 72 divided by 12 is 6. So our probability is 1 over 6. Okay. So that's how it works now when we're doing it without replacement. There's less marbles the next time you go to pick one. Let's try another one. We're going to use the same bag of marbles again, but this time I want to pick 2 orange ones. Let's say orange is my favorite color. I want to get both of the orange ones without replacement. All right, so again, we see those words without replacement, and we know we're dealing with dependent events. So what's the probability of picking an orange one the first time? Well, there's 2 orange ones in the bag, and there's 9 total in the bag. So 2 over 9 is the probability of the first orange. All right. So the next thing we want to do is figure out the probability of the second orange marble. Pause the video here real quick and see if you can figure out what the fraction is going to be for the second orange marble. Then start it back up again and see if you got it. Okay, hopefully you did that. Once I've picked one orange marble out, this affects both the top number and the bottom number because how many orange marbles are left? Just 1. So if I've picked one out, there's 1 left. How many marbles are total left in the bag? 8. So this is the probability of the second orange marble. Now we go to multiply. 2 times 1 is 2. 9 times 8 is 72. Both of these are divisible by 2. 2 divided by 2 is 1. 72 divided by 2 is 36. So our probability is 1 over 36. So it's extremely less likely, right, that we're going to pick both of the orange marbles without replacement than it would be to like pick a blue and then a green, which hopefully makes sense. There's more blues and greens in there than there are orange. Okay, so that's dependent events. The last thing we're going to talk about today is sample spaces for compound events. So if we think back to yesterday real quick with sample spaces, that was like we were looking at all of the possibilities of things that could happen. And we were looking at like specifically the number of possible outcomes. So with compound events, there's more possible outcomes. For example, or let's actually talk about that real quick. So we're going to look at the number of outcomes. And when there's more than one event, the number of outcomes is going to be the number of possibilities from event 1 times the number of possibilities from event 2. And then if there were more events, you would just keep multiplying, like number of possibilities from event 3, event 4, event 5, which gets out of hand really quickly. But let's just look at 2 events to start with. Let's say I flip a coin and spin this spinner. All right. So event number 1 is the coin flip. Doesn't really matter the order so much, but when you flip a coin, how many possibilities are there? Well, you can get heads or tails. So there's 2 possibilities. So that's the coin flip possibilities. And then when I spin the spinner, there's 4 different sections. So there's 4 different things it could land on. So I'm going to multiply by 4 because that's the spinner possibilities. So 2 times 4 is 8. That is our total number of outcomes. Okay. So you're just multiplying the number of possibilities from each event. All right. So we're going to make up one for you to try. Let's say I choose a card from a stack of 8. And roll a 6-sided die. All right. Pause the video here real quick, see if you can figure out how many outcomes there will be, and then get it started again and we'll talk about it. All right. Hopefully you did that. For the first event, there were 8 cards. So there are 8 possible things, 8 possible outcomes from that first event. The second event, there were 6 sides on the die. I rolled it. So that means there were 6 possibilities there. That's a total 8 times 6, 48 possible outcomes. That's the 48 basically combinations of things that could happen, right? I could choose one card and roll a 1. I could choose that same card and roll a 2. And, you know, so you've got all of these different combinations of things that could happen. There are 48 combinations of possibilities. All right, so quick recap. Here's what we did today. We talked about independent events, things without replacement, or when you put it back, or they're unrelated. Dependent events, so things like if I picked a marble and then I kept it out without replacement, stuff like that. And then we also did sample spaces for compound events. So if I spun a spinner and flipped a coin, how many possibilities are there? All right, so time to go get started on that homework. Hopefully this was helpful. Have a great rest of your day.